Okay, so I'm just gonna quickly type up the code that we did last week. Um, yeah, just quickly type the code that we did last week, and then this I'll quickly demonstrate it, and then I'm just gonna quickly type some stuff out. Um, basically I will paste it in the chat, and I want everyone to demonstrate that. So basically, this is what we done last week. Um, so I'll just quickly revise what we have done. Um, when we get to this. So basically, we're going through lists again. So as you can see, I'm typing out the lists of stuff of like sequences that you want Edison robot to travel in. Um, just give me a sec while I try to finish off this code. Um, and then Yep. Okay. So now what we're gonna do is we did a list of formulas and stuff from starting from 0 to 3. So like in coding, 0 um, is the first number in coding. So instead of like step number 1, you always start with step number 0. This is something you come familiar with later on when you do some more coding if you decide to continue on that path. So I'll just quickly type out the code. If you don't understand, that's fine. I'll just quickly type this all out. And then we just do 10, and then we'll make a drive. We'll make a drive, and then we'll go make a drive forward. We'll make a drive forward. We'll do at speed 5. At speed 5, and we'll make it drive forever. Um, distance unlimited. Okay, and then now, once it dries, we will wait until detect the obstacle. Read obstacle detection. And if you can't see the obstacle, you will pretty much, if you see the obstacle ahead, make sure you don't see those double ed. Otherwise, it will be very, very hard to it will not run. The code will not press and it will not run. So I'll just quickly demonstrate this after typing and finishing typing this code. So basically what the code would do is, the sequence of the code is that you turn on the obstacle detection beam. The obstacle detection beam will allow the Edison robot to detect what's ahead, what's behind. So it will be able to detect when to stop. This will be very useful later on. So you have a list of move, which is pretty much like you create like a special list where you have 4 slots in the list. Slot 0, slot 1, slot 2, slot 3. So the 0 step, which is pretty much the first step, but like you subtract 1 because it's coding, right? You drive forward. The second step, or the first number 1 step, is to drive backwards. The number 2 step is to spin left, and number 3 step is to spin right. So it's gonna, because the thing is like we have 10, so it's gonna drive forward for 10 centimeters, backwards for 10 centimeters, spin left for 10 degrees, and then spin right for 10 degrees. So this function here, this command will iterate and loop through all of this. So you can choose like by the number, which index, which place in the list you pretty much run and stuff. And then you make it the Edison robot to drive forward forever, for like literally until you make it drive forever until it detects an obstacle ahead. When you detect an obstacle, it will stop. Otherwise, if you haven't detected an obstacle ahead, it will keep running through this loop over and over again. So what I'll do is I'll install the program and I'll try to run it on my end, and then um, I'll ask you to run it on your end, and then we'll move on to the next part, which will be logic, as we almost like wrap up this course. So What I'll do is just run this code again, just set it up and run this code. So just give me a sec. It's going to take a while because of the fact that there's a lot of code, so it's going to take you a while as well. Any minute now? Yep, now it runs. Okay, so what the code will do is quickly show my code. So this is pretty much what it would do. You drive forward, backwards, spin left and right, and then it will drive forward for infinity until I have something like a hand or say a water bottle or something that will stop, that will tell the Edison robot that there is an obstacle ahead, and then if the code works, it will stop. So there's no error. We have this run. So this is what's going to happen. You drive forward, backwards, left, right, and then drive forward, and then you put my hand in front of it, and then it will stop. So let's try again, and then it will keep driving forward until my hand is in front of it, and it will stop. So I'll give you all until 6:15 to get this done. I will paste this code into chat. Um, I'll paste the code in the chat. Literally place it in your code below, and then we'll get this running. So I'll give you all until 6:15 to get this working. Any questions, just raise your hands, or the Brilliant Kids admin will tell me if you message in the chat. Yep, you have until 6:15. When we get 6:15, please someone demonstrate. If you're done early, let me know so we can demonstrate early as well. Awesome, you have all until 6:15.
Okay, anyone need help? Okay, Alex, good. I can see that you got it working. Let me see. Let me see who's needing help here. I have spatial. What's your name? Can you type your real name?
Okay. So when I do it, it just it lets me do it. And when I do it, it makes a failure sound.
When you program it, or you try to do it?
Program it.
So if anyone was trying to ask a question, I didn't see because of the fact that I plugged this inside, you know. So
Okay.
so, yeah, what's the question?
Can you? What's your real name? I can't pronounce your name.
I'm trying to rename it.
What's your name?
I just renamed.
I can rename it for you. I can't.
Sam, right?
I just did.
Oh no.
Sam. Okay, Sam. All right, that's good. So you have problem with programming it?
Yeah, what's the issue?
So when I go to program Edison, it lets me create the WAV. I've done the check code, and then when I go to program it, I press program Edison, and if the failure noise comes out of the Edison.
Have you pressed the circle button before you hit the program?
I did.
You did press the circle button?
Yeah, I did.
Have you increased the volume to at least 70%?
I put it on 100%.
Oh, can you retry? Because
okay.
Maybe try first thing is turn on and turn off your Edison robot. Make sure you do the same installation steps. If it doesn't like work out, then I suggest you try to just change your batteries and stuff.
Okay.
Awesome. Oh, we have 3 hands. Okay, let's see. 6. Who wants to demonstrate? Alex, can you demonstrate? I think I saw you run yours already, but can you demonstrate for the whole class? Okay, let's see how you go, Alex. Oh, good job, Alex. Good job. Wait, does it keep moving, or is it like does it still move, or it stops completely? Yep, perfect, awesome. Okay, who else wants to go next? Aisha, you want to demonstrate? Okay, Aisha, do you want to demonstrate? No? Okay, who else wants to demonstrate? Anyone wants to demonstrate? Does anyone in the chat want to demonstrate?
how about Jen? Normally,
Okay.
Jen will be Aaron is also quiet today.
Okay. Okay, who else wants to demonstrate? If not, we'll move on. Does anyone have any questions about this? Does everyone have a general idea how this works? How list works? What this does? What this does? And what this does? Does anyone have a general understanding? If anyone has any questions, let me know before we move on.
We don't expect you to copy and get it working. we also expect you to understand it why it's working. Does it make sense to everyone? You need to understand the concept of list. Shani, okay. I mute you.
Yep, what's the question?
My robot's actually not working.
Your robot's acting what?
Not working.
Oh, okay. Yeah, I suggest you change your battery.
Yeah, we just changed them, but it's still not working.
Okay. Is your code having like errors and stuff? Do you see any errors in the code?
No, so I programmed it, but when I press the triangle button, or I can't remember, it goes like this.
It goes.
It means
Okay,
your program's got nothing.
Yeah, make sure you put it below your code below part.
What it means is your code is got nothing in there.
So yeah, make sure you copy and paste this properly, and then yeah, we can go on from there. Awesome. Aisha, what's the question?
Aisha, can you unmute?
Yes.
Yeah, what's up, Aisha?
When we do program Edison to the robots, it doesn't, and then we say play. It doesn't want to work.
It doesn't work. Okay. Did you put your code exactly like this?
Yeah.
Exactly like this. Okay. So, do you know how to program your Edison, right?
Yeah.
Okay. So just tell me tell me the exact steps that you do.
I did program Edison, and then I pressed 1 times square, and then after the Edison finished, I took off the.
Okay. So I think you might be getting the steps wrong. Just remember, you connect this. Of course, you got that step right. Make sure you press the circle, not the square, but the circle. It's the circle button.
Yeah, I
press that.
I did wrong. I pressed the circle, not the square.
Okay, you press the circle, yeah, and then you press program Edison, right? Does it like load on the stuff, right?
No, I don't know.
Okay, so make sure you connect and program Edison. Wait for this to create, and then press program Edison. Initial program. Try that. And if there are any issues, just let me know. Okay. Does anyone have any other questions before we move on? Nope. Okay, let's move on. Okay, so we're going to introduce logic into your Edison robot now. So we're going to introduce this condition, this concept called if and else statements. So how it works is like, I'll just give an example, right? We'll just maybe just create a variable called x, called x, and we can set this equals to 10. And then we can do this. So the thing is, if x, we can check if x is equals to 10, we can make the Edison robot drive forward. We can make a drive. We can just do add dot forward. Add dot forward. We can do dot whatever speed rocks your boat. Add speed, maybe add speed 4, and we can do say like around probably like 15 centimeters and stuff. So before I run the program, right? If I press if I program it and run it, what will happen? Can anyone want to give a guess? Does anyone want to guess? Okay. I'm sharing my screen, so it's hard to see. If there's any good answers, just raise your hand and tell me.
They ask why you put the 2 equal sign in the if
Okay.
statement. They ask that,
Okay.
which is a valid question.
Yeah, that doesn't make sense. Yeah, that's good. That's a good point. So, so there's two things that you should keep in mind. So first of all, like the equal statement is pretty much like 2 equals means we can check if x is equals to 10. But the thing is like equal is very generic. 1 equal is very generic. We want to do another equal to make it more specific and stuff. So I'll give you an example why we need to use 2 equal statements. Because we want to, first of all, so this will check if x equals to 10. But let's say x is not equals to 10. So we have this exclamation mark. It pretty much says like if x is not equals to 10. So this is like an inverse. This is an opposite. So it checks the opposite condition. So if you want to check if something is not equal to something, you add the exclamation mark. So if x is not equal to 10, then you run this code. Otherwise, if x equals to 10, it will run this code. So I'll just ask a few questions before I run. Give you a chance to answer a few questions before we try running the code. So, who wants to give a guess? What would this program will do? Anyone wants to raise their hands? Or anything valid in the chat? Any questions in the chat?
Not yet. We're still looking for people to brave enough to. It's okay to make mistake.
Actually, let's make it easier. Everyone put a thumbs up if you think the Edison robot will drive. Put your thumbs up if you think the Edison robot will drive. I can't see anybody's. Yep, I can see some thumbs. Awesome.
Farad did that. Okay.
Awesome. If I put this to number 9, if you think it's gonna run, put your thumbs up. Otherwise, you just put your thumbs down. Do you think this will run? Put your thumbs up if you think it's still gonna run.
Watch it set. It's a thumbs up. Greg is a thumbs up.
Lewis, you say it's a thumbs up.
Piesha is thumbs up. Louis thumbs up. Sam thumb up. So it's gonna drive.
Okay, so the first one, if x equals to 10, it will drive. But if x equals to 9, how the program works is if x is equals to 9, it will check if we set x to 9, then the program will check if x is equals to 10. We can tell this by the double equal sign. It basically, x, which is 9, is not equal to 10, so it will not drive, so it will not run at all. So let's just try this. I'm going to program this and see if it works. So I'm just going to program this right now. Okay, so now it's going to run because x is equals to 10. But now let's just change it to see if x equals to 9. If x equals to 9, it will not run. So I'll program this. and just show you it's not going to run. Maybe I'll just add one more thing. It's going to drive backwards. Because if it's not going to drive forward, it's going to drive backwards. Oh yeah, that's a better idea. Else, if it doesn't work, if it's not equals to 10, it will drive. If x is equals to 10, it will drive forward. Otherwise, it's going to drive backwards. So let's do this backwards. Okay. So, okay. So before I continue, who thinks it's going to? Okay, put your thumbs up if you think it's going to drive forward. Otherwise, thumbs down if it's going to drive backwards. Yep, Lewis has his thumbs down. Yep, Sam, thumbs down. Awesome. Yep, that should be correct. So let's try programming this right now. It's taking a while. Just give me a sec. Right, just let me program this again. Okay, so now what do we do? Who thinks is okay? So it should now drive backwards because of the fact that it does not x does not equal to 10. Okay, so I want you all to write this code, but change x in a way that will make your robot drive forward. So I'll give you all 5 minutes. Let me know. I've accidentally unmuted my connected this so I couldn't hear anyone earlier. So I disconnected so I can now hear everybody. Any questions, just let me know. So basically, yeah, set x in a way it will drive forward. You use the same code, but set x in a way it will drive forward. Yep, so Lewis, you raise your hand. What's up? Oh, you unmute yourself. Please unmute yourself.
So I think I've done it.
Okay, awesome. So let's see
So
you demonstrate.
I've changed the x to 3. X equals 3.
Yeah, and then drive backwards or forward.
Well, it drives backwards and then it kind of swells a bit.
Okay. That's
It does a bit
interesting.
of a.
So it swirls. Wait. How did you set your code? Wait. So the it drive forward. Okay. So there must be some issues with your battery if it makes this
Well,
random swirl.
we just reset the batteries and it was.
Yeah. Okay. There must be.
I think one of the motor might be spinning not fast enough
Oh yeah, that's true. That could be another thing. Maybe we can set this
because
like
you do
slower.
speed is too fast.
Yeah, you could set it slower.
It's like skidding on your table.
Yeah. Okay. Awesome. Well, good job, Lewis. Okay. So I'll ask you, what will you change X2 to make it drive forward then?
Me?
Yeah.
Yes.
What
Yeah.
if you?
I changed it to 3.
Okay.
That's
What
backward.
would you do? What would you do to make it drive forward?
2, maybe.
Okay. So I'll get back to everyone on that. Who else wants to demonstrate? Okay, 6:35 now. Does anyone else want to demonstrate? Nope. Okay. Well, thank you, Lewis, for demonstrating. So what you would do is, let's just explain the concept of the program. So x is equals to 9. You run the program. You check if x is equals to 10. Is x equals to 10? Thumbs up or thumbs down? Is 9 equals to 10? Thumbs up or thumbs down? So if it's yes, thumbs up. Otherwise, if it's no, thumbs down. Exactly. So it is not equals to 10, so drive backwards. So, okay. Can someone type in the chat what you have to change x to make it equals to 10? And then the Brilliant Kids admin will let me know if whoever gets it correct.
Greg says 10. X equal
Yep.
to 10.
Precisely.
Greg.
Awesome.
Good job, Greg. When you will get the camera and mic?
Okay. So
he joined
now,
the full lesson for the 10 lesson and we cannot communicate with him, which is a pity. He's pretty smart.
hopefully soon. Yeah, hopefully
Yeah.
soon. Okay. So now what we can do is we can check if let's just do one more condition at the end to check if let's just say later down we can check if x equals to 9, or let's say if the x is equals to 9, or we'll explain to you that's something as we've taught. If x is not equals to 10, or I have a better idea. If x is not equals to 3, that's what Lewis put in earlier, we can make it a drive, and then we can make it add spin. Wait, is there, let me see, what is there a special spin? Add spin. Yeah, we can make it spin left, spin right. Yeah, we can do spin right. We make it like slightly slower, so even anyone with issues can make it without any skidding or any issues like that. We can make it spin 360 degrees, make it spin around. So yeah, so what I will do is if the number is not equals to 3, it will spin around in a circle and stuff. So I'll just try demonstrating this on my end. And then we can also check if x is equals to actually I will do that later.
Should we teach them the switch statement?
Oh no,
That's
that's a bit more advanced.
That's a bit more advanced.
That's a
Okay.
bit more advanced, yes.
Okay, that's cool.
Okay, so who thinks the Edison robot will spin? Right, thumbs up if you think it's going to spin. Otherwise, thumbs down if it's not going to spin. Who thinks it's going to spin? Thumbs down. Samuel's thumbs down. Jen is a thumbs up, I believe. Yep, Jen is a thumbs up. Who else thinks it's going to be? Yep, Shani is thumbs up. Lewis is thumbs down. Aisha is going to be thumbs up. Tia is thumbs up. Waji is thumbs up as well. Awesome. Okay, so let's just see, and let's see how this runs. Okay, so let's go. So, as you know, since x is not equals to 10, you drive backwards, and then it'll spin. So, okay, so why does it spin? Because what x is the number 9. 9 is not 3. 9 is not 3. So it will spin to the right. Otherwise, we can do another condition. We'll introduce another condition here. Else if, we can do another check. Else if x is equals to 9. Well, so else if x is equals to 3. Else if x is equal to 3, we can do it. We can make it spin left. Spin left. And yeah, so we can also do else as well, but like the opposite of checking if x is not equal to 3 is x equals to 3. So we can also do else. Else would work, but we want to be more specific in the condition, so we use else if. So who thinks is gonna, if I change this to 3, which direction will this spin? Point your thumb. Actually, no, it'll be hard. If you think it's gonna spin right, put your thumbs up. Otherwise, if you think it's gonna spin left, put your thumbs down. If you think it's going to spin right, thumbs up. Otherwise, spin left, thumbs down. Yep. Okay. Alex, you put your thumbs down. Aisha, you put your thumbs down. Sean, you put your thumbs down. Okay. Oh, Aisha put her thumbs up. Okay. We'll see what happens after this is installed. Okay. So let's run the program. What happens? Okay, so let's just put this down here. Oh wait, sorry. So let's just put this here. Well, let's just I'll just put this in front here. It spins left. So this is left, this is right, this is left. Who wants to explain why it spins to the left?
Can anyone brave
Does anyone
enough
want
to
to explain?
explain why spin move backward and spin left? It's okay. It's okay to make mistake. That's how you learn.
Is there any good answers on the? Yeah, it's fine. Is it going to be okay? So, does anyone know why?
Probably Leon put in the chat seems to be correct.
What did Leon say? Can you read it out?
Spin left because x is 3.
Yep,
And
that's
if x
precisely
is
the
not
reason why.
3, it will spin right. But since x is 3, it will spin left.
Awesome. Okay, so um, I want to give everyone a challenge. So copy this code. Copy this code here. I'll actually paste it in the chat. Okay, copy this code here, and then change the number of x in a way that will make it drive forward, then spin right. This would be a challenge. So I'll give everyone um, give everyone 5 minutes to get this done. It is 6:50. Any questions? Just raise your hand, or yeah, any questions? Raise your hand, or just the Brilliant Kids admin will let me know if you put us in the chat.
Sorry, Peter, what's the challenge? Somebody will ask it.
Okay, so the challenge is to make your Edison robot drive forward, then spin to the right. So drive forward, just change the number, change his number. That'll make the Edison robot drive forward and spin to the right.
Okay, I put the challenge on the chat. Okay, everyone.
Yeah, sure. You got to 6:50 to answer.
5 minutes, everyone. Alex, you have a question, Alex?
I didn't have a question. I just want to demonstrate.
Yeah. Can you turn off the background? I can't see it. Okay.
Good job, Alex. Let's just see you demonstrate. Okay, wait, just show, do it again.
So you drive backwards and turn left.
Okay. So, what number?
What number did you put, Alex?
I put x equals 3.
Okay, so x equals 3. Let's just see what the program would do. So x would check if x equals to 10, x is not equal to 10. So it will not do this. It will not drive forward. It will just drive. Else it will just drive backwards because x is not equal to 10. Since x is not equal to 10, it will drive backwards. They will check if x equals to 3. If x is not equal to 3, but the thing is x equals to 3, then it will spin left. So you just have to change the number just to figure it out.
Okay.
I'll give you all 3 more minutes.
Yeah, I can see some people got it working. If you need help, raise your hand. Sam, you have a question, Sam?
Okay. So I just changed it, and it said syntax error. Nested classes are not supported in Ed5.
Okay, so Okay, can you copy and paste your code, or actually, did you? Okay, let me ask you. Have you indent your code? Do you make sure that
Again?
this? Did you indent your code? Make sure there's 4 spaces between here. For example, after the if, or else, or if else, make sure there's like 4 spaces between between the n and this point. So 1, 2, 3, 4, or you can press tab. So try that, see if that works. If not, just copy the paste the code I've given you.
Mhm.
Okay. Yep. Okay, with 1 more minute left. Okay, so who would like to demonstrate? Actually, it's 6:50 now. Who wants to demonstrate? Jen, I can see your Edison robot is ready. Do you want to try? Oh, nice. Good job, Jen. Okay, what number did you end up putting in?
Just type in the chat, Jen.
Yeah, type in the chat. Yeah. What did she put in?
Or you can unmute.
Okay, Lewis, you know what's up, Lewis?
I'd like to demonstrate.
Yep. Okay, let's
Please.
demonstrate, Lewis.
Okay, so this is the code.
Okay, what number did you do?
3 and 3. And then this is what it does.
Okay.
Yeah, just move that out of the way. Whoa. Goes back and does a 360.
Okay, that's good. So it goes back and turns left. Okay, awesome. Thank you
Yeah,
so
so
much
it
for your
goes.
demonstration.
Yay.
So
Can
the
you-
thing was a bit less now.
Yeah,
Okay,
can you try to do go forward and spin right 360?
Yeah. Yep.
Okay. Well, since we should move on from the exercise, but we should move on from the exercise, but basically the number you should put is 10. The number is 10 because why? If you check with 10, right? If x equals to 10, which it is, the program will check if x equals to 10. It is, wait, sorry, let me rephrase this. The program will check if x equals to 10. The thing is, x is 10, so it will drive forward. And they will ignore all of this stuff here. And they will check if x equals to 3. The thing is, like, x is 10, which is not equal to 3. So therefore, it will spin right. And it will ignore the thing that tells you to spin left. Okay, so what we'll do is I want to introduce this other code. Just give me a sec. Okay, so maybe. Okay, so what we can do is I'm just going to introduce this here. Hmm. Okay, so what we'll do, I'm just gonna copy this. Let's just see if this works. So or at the end, it will check if you can hear if the Edison robot hear clap or something. I'm just going to add this while true. It's going to keep running this, and then it will check if you can hear clap. If you hear clap, then it will play a beep. So I'm just going to do add play beep. Oh, actually, I'll play tune. Play tune. What tune shall we play? Nah, I'll just do play beep. Make it simple. Add dot play beep, and then maybe does it break? Yep. Let's see if it works. And it will break. It will exit this loop. So what it will do is you'll drive forward, spin right, then you check if it beeps. You play a beep. I'll make it say when drive forward for an extra like maybe drive forward, maybe speed 7, lucky 7, for like 30 seconds. And then I'll play a beep again, and we'll break this loop. So I'm just gonna try running this on my end and see if it works. If it works, then just let me turn this on. Wait. Okay, so there's a syntax error. Oh yes, I put this wrong. It should be add speed 7. So this is what it should do. So I'll check if the code will work. Let's just check this. There's no errors. Okay, so let's program this.
Going to run. And it's installing right now. You should finish any time now. And then what we'll do is, I'll just show my thing. So what we'll do is you drive forward, spin right, because x is equals to 10, which is not equal to 3. Okay, wait, let's just try again. Okay, so maybe because of the fact that it's a bit sensitive, so maybe let's just, how do we can just make the Edison robot wait. Let's just Edison, it's a bit confusing. That's fine. Let's just see what time wait does. We can make an Edison wait for like 3 seconds. So we can do 3, and we can do add. We can make it add a time seconds. We can make it wait for 3 seconds, and then you run. Let's just see if that will run. If we don't get this done on time, we'll continue with this next lesson. Okay, there's an error. Okay, so what is the error here? Doesn't add ti doesn't have a value yet. What's the issue here? Add dot time wait. Okay, so what's the issue here? Add dot does not have a value. Okay, let's just check the code. If there's any issues. There's no error? Okay, so let's try programming this now. so let's see if it works. If it doesn't, we will continue on with this next way. So let's try with this. And then you stop a bit, up and clap, and it will drive forward. And then wait for a few seconds. Then I clap. I'll make a sound, it will go forward. 1, 2, 3. This is very sensitive, so you should be able to hear things very loudly. Okay, so does anyone have any questions? We can continue with this next week. As we enter our last class, we'll introduce functions, and then we'll see where things will go. So yeah, I'll probably leave the class early, wrap up this class early. We can continue with this next week. We'll introduce functions, and we'll be able to get more things done. The Edison robot.
Yeah,
So yeah,
I don't think it's early. It's 6:59, so it's spot on time actually.
yes.
All right, everyone. I'm sorry. We finished now. I'm gonna unmute everyone. We got one more class next week. With the concept of function, which is very important. So I really hope you join next week. Okay. For now, just unmute everyone. Say goodbye to Peter.
Bye.
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 See you next week.
Bye.
Bye.
See you